So this is level 1 simulator challenge. Level 1 means the engine does not start. It may crank but will not start. And that's exactly what I have here. It cranks but won't run. So today I elect to check the fuel pressure first. Yeah, and I realize there's no fuel in the rail. So next I bring out the diagnostic tool, which is able to communicate with the vehicle and has a slew of codes, but I pay particular attention to the last two, which are related to the ECM power relay control circuit. So now that is going to be my area of investigation today. I need to to examine that circuit, see what's wrong with it. Everything else about injector circuits and fuel pump relay circuits is downstream of this ECM power relay, as you see in the wiring schematic. So there's no need for me to keep the fuel pressure gauge. I've seen the ECM is not powering up altogether, so I remove the fuel pressure gauge. And here is where the ability to read and understand wiring diagrams becomes key, because I now decide to spend quite some time examining this wiring schematic to develop a plan, testing plan. Remember the ECM, the diagnostic tool has indicated that the PCM is alive, yes, but it has fault codes for injector circuits, ECM power relay, and the fuel pump. So the ECM is not totally dead, but I need to find out what's up with the circuit for the main relay. As you can see from the wiring diagram, that relay feeds the EGR valve, evap canister valve, all 4 injectors, and even the throttle control valve. So those have all gone out. You can see on the wiring, that tree, they really has one input circuit or side, and then it has 2 outputs. One output is related to the fuel pump, and the other leg of that output terminal of the relay is related to the 2 valves that I mentioned earlier, the EGR and the evap, and all 4 injectors, and the throttle control valve stroke module. Yeah, so after examining that wiring schematic closely, I now need to bring the multimeter out. I've spent some time doing my my homework, so I know it is the relay of interest is K2, and that's the one that I need to be testing. It has 5 wires. 2 of those must have battery voltage at all times unless the battery is removed from the vehicle. 2 of those should have battery voltage with the key in the on position. They will be at 0 with the key off in the off position, but should have battery voltage. Those are the ones that feed all the actuators that I mentioned earlier. And then there is one wire, the black one, that should have battery voltage before the key is turned to the on position, but should be grounded, should go to 0 once the key is turned to the on position. So to understand what the issue is, I test these wires going into and out of the relay. I'll bring out the wiring diagram again to guide me. That wire, that black wire, should have 0 volts. It should be grounded with the key in the on position. That's the wire that the ECM uses to control the ECM power relay. And now I pause there to look at the wiring schematic again to be sure that I'm seeing what I'm seeing is right. So those 2 wires should have battery voltage, correct? And then these other 2, the blue one and the orange yellow, should also now be having battery voltage with the key in the on position. The black one, though, like I said, should have 0 volts now, should be grounded by the ECM. So clearly, I need to inspect the ECM relay control circuit in further detail. So to confirm what I'm seeing about the ECM control, I use the actuator test on the diagnostic tool to play with the control of that wire. As I'm playing with toggling that switch, the voltage on the multimeter at the relay should go to 0, but it doesn't. So that means the relay is not receiving the control command from the ECM. So now, is that happening only at the relay, but it is correct at the ECM itself? I need to find out now whether I'm having an open wire between the ECM and the relay. So that requires me to dig the breakout box to be able to test this wire, that black wire, at the PCM itself. So that's my next step. Doesn't look good. Doesn't look like I have an open wire. So everything is now pointing towards the ECM itself. The fact that the ECM can communicate and give us fault codes tells me the powers and grounds for the ECM are good. So that pin 8 should be grounded every time the switch is turned to the on position for the ECM power relay to come on. So I make the decision to replace the ECM with a new one, and after replacing it, I have to program it to the vehicle. Yeah, you can hear things are starting to move. That means it's rotor motor. And the engine now runs. Yeah, so the fault was a bad ECM. To reiterate, okay, now I need to clear the fault code, but to reiterate, I spent some good time looking at the wiring schematic. I did my homework so that I spend little time on the vehicle itself. By the time I came to the vehicle, I knew exactly what to look for. It became quite clear early on that I'm having issues with the ECM power relay control circuit. So it's now time to to fill the work order and release the vehicle. So I informed the supervisor what my findings were and what I did to fix the vehicle. First of all, I diagnosed that the ECM was not turning the main ECM really on as it should when the key is in the on position. My next step, after double checking that the issue was with the ECM, my next step was to replace the ECM and program it. And the issue is now resolved. The engine runs and the vehicle can be returned to the customer. Yeah, it does say that the memorized fault codes. Yeah, I must have created a fault code in the gateway when I was removing the breakout box from the when I was returning the breakout box to the store.